Hello there, fellow explorers of the cosmos. Welcome back to our digital odyssey. It's your friendly guide, Dr. Astra, here to demystify another intriguing marvel of our universe. Today, we're stepping away from the vast expanse of the cosmos and diving into the mysterious world of the infinitely small. Our journey takes us into the bewildering and paradoxical realm of quantum computing. Here, we will unravel the intricate layers of this revolutionary technology, exploring what it is, how it works, and how it could potentially revolutionize our world. Part 1. What are quantum computers? Let's start with a basic question. What exactly are quantum computers? You might have heard this term tossed around in the tech news, linked with big names like IBM and Google. But the idea of a quantum computer goes far beyond its alluring name. It's a fundamentally different way of processing information, a jump as significant as the one from the abacus to the digital computer. Quantum computers operate on the principles of quantum mechanics, the laws of physics that dictate the behavior of particles at the smallest scale. Unlike classical computers, which process bits of information as zeros and ones, quantum computers use qubits. Now, what's so special about these qubits? Here's where things start to get a little quantum. A qubit can represent a 0, a 1, or any state in between, all at the same time. Yes, you heard that right. This is what we call superposition. Imagine being able to be in two places at once. That's the kind of magic we're talking about here. To part 2. How do quantum computers work? So, how do these extraordinary machines work? How can something be both here and there, a 0 and a 1, all at the same time? To understand this, we delve into another mind-boggling aspect of quantum mechanics called entanglement. In an entangled pair of qubits, the state of one instantly influences the state of the other, irrespective of the distance between them. It's as if they are dancing in unison, perfectly coordinated, no matter how far apart they are. This weird correlation allows quantum computers to process a vast amount of data simultaneously. But the quantum realm is not all fun and games. There's a catch. You see, the act of observing a quantum system changes the system. So while a quantum computer can process a massive number of possibilities at once, as soon as we measure the system, it collapses to a single answer. This paradox is one of the biggest challenges in harnessing the power of quantum computing. Part 3. The promise of quantum computing. You might be wondering, why should I, an everyday person who's not a quantum physicist, care about quantum computers? Well, let's look at a few examples to illustrate the magnitude of their potential, especially for problems that we face in our daily life. Take, for example, the challenge of weather forecasting. Weather simulations are complex, and conventional computers can struggle to deliver accurate results quickly. With quantum computers, we could potentially analyze enormous amounts of climate data, predict weather patterns, and provide accurate forecasts faster than ever. Imagine being able to predict a hurricane's path weeks, not just days, in advance. That's life-saving stuff. Then there's traffic management. Have you ever been stuck in a traffic jam and thought, there's got to be a better way? Well, quantum computers could be the answer. They could process all the possible routes in a bustling city in a heartbeat, optimizing traffic flow in real time. No more late arrivals because you got stuck in traffic. What about medicines? Creating new drugs involves simulating different molecular structures and their interactions, a task that's incredibly hard for classic computers. But quantum computers could change this game completely. They could help us analyze and simulate complex biochemical reactions efficiently, potentially accelerating the discovery of new medicine. Estimating how fast a quantum computer can solve these problems is tricky because it depends on the problem's complexity and the computer's design. However, as we saw with Google's Sycamore experiment, the potential speed-up can be astronomical. We're talking about performing complex calculations that would take current supercomputers thousands of years in mere minutes or hours. Part 4. The current state of quantum computing. This brings us to the present. Where are we in this quantum journey? Have we achieved the sci-fi dream of powerful, efficient quantum computers? Well, in short, we're making strides, but we're not quite there yet. Quantum computers exist, yes, But they're far from perfect companies like IBM. Google and several startups are racing in this quantum marathon. They're constantly experimenting, tweaking, and refining these extraordinary machines. For instance, Google's quantum computer, Sycamore, demonstrated quantum supremacy in 2019 by performing a calculation in just over 3 minutes that would take the world's fastest supercomputer approximately 10,000 years. Impressive, right? But remember, this was for a very specific, carefully chosen problem. The reality is, we're still grappling with quantum noise and qubit instability, which can introduce errors and limit the computer's ability to maintain its quantum state. Additionally, keeping these qubits at near absolute zero temperatures for stable operation presents significant engineering challenges. We're also learning how to program these new machines and develop useful algorithms. So, while we have prototypes and proofs of concept, we don't quite have a quantum computer ready to revolutionize your daily life yet. But that's the adventure of science. It's a journey of constant learning, questioning, and discovery. The conclusion. And there you have it, folks. The quantum realm, as mind-boggling as it might be, holds immense potential. Quantum computers, though still in their infancy, promise to take us to places beyond our wildest imaginations. We're on the cusp of a new era, an era that might just witness the birth of a new era, an era that might just witness the birth of a quantum revolution. So keep your eyes peeled and your mind open. As always, I'm Dr. Astra, signing off until our next cosmic journey. Remember, the universe is filled with mysteries, and the joy is in the journey of discovery. Until then, keep looking up and stay curious,